You check your data, review the curve, and the reality sets in. Your biomarker assay just failed its freeze-thaw or benchtop stability test. That single failed result means lost time. It destroys confidence in the assay, and if left unchecked, it can stall an entire development program. The standard response in most labs is to panic, tweak one minor variable, and immediately rerun the exact same test. But single variable reruns almost always fail again. Stability drops are rarely an isolated fluke. They are complex system issues driven by sample handling, matrix interference, or active degradation. To actually save the assay, you have to stop guessing. You need to treat the failure as an assay development problem, using a strict 6-step diagnostic protocol. Step 1. Reconstruct the exact failed workflow. Look at this side-by-side comparison. On the left is your pristine standard operating procedure. On the right is what physically happened on the bench. You have to map out the hidden 10-minute delays, the exact plastics used, and who actually handled the tubes, rather than what the document says should have happened. Step 2. Isolate assay drift from sample drift. Before you run another patient sample, examine your calibrators, your quality controls, and your plate location patterns to find the exact source of the drift. If your controls and calibrators drift alongside the authentic samples, the assay itself is broken. But if the controls remain perfectly stable while the authentic samples plunge, the problem is isolated directly to the biological sample or the handling environment. Identifying whether the assay machinery or the sample biology is failing determines the entire direction of your subsequent investigation. Step 3. Analyze concentration dependence to see exactly where on the curve the failure occurred. This bar chart maps concentration levels. Failure exclusively at the low end points to sensitivity limits or tube adsorption. Notice the shift. High-end failure suggests hook effect compression or dilution errors. Flat loss across the curve means bulk analyte loss. Step 4. Compare native samples with spiked or contrived material. Relying entirely on spiked quality controls is dangerous. They can easily give you a false sense of security during a failure. If your spiked samples pass, but the native specimens fail, the true culprit is biological context. You are likely dealing with endogenous binding partners in the patient matrix, or native matrix viscosity. A passing spiked sample does not prove your assay is fine. It merely proves that the instability is uniquely triggered by the true biological environment. Step 5. Challenge handling assumptions directly. Do not run a massive stability protocol yet. Instead, run targeted mini-experiments contrasting extremes. Test immediate versus delayed dilution, or thaw on ice versus room temperature. Individual variables often seem completely harmless on their own, right up until they interact with another factor, like your thaw temperature heavily interacting with your buffer composition. Step 6. Use design of experiments, or DOE, to lock the workflow. This 3D surface plot visualizes a design of experiments. It mathematically maps out exactly how these suspected variables interact, revealing the precise, safe operational boundaries for your assay. You use this data to aggressively rewrite your sample handling windows, your aliquot strategies, and your plate loading rules. Replacing guesswork with quantified interaction mapping is the only way to build a protocol that will survive the normal, daily chaos of laboratory variability. Which brings us to the ultimate rule of stability testing. You must only repeat the formal stability assessment after the revised workflow is locked in with DOE data. This restraint pays off. You avoid the nightmare of validating the wrong workflow, and you prove to regulators that the assay is genuinely fit for its intended purpose. Method development is exhausting when you are stuck in a loop of failures. If this roadmap helped you chart a path out of that frustration, please hit like and subscribe, and share your current stability nightmares down in the comments so the community can troubleshoot the next problem together.